Hello everyone. I'm going to do two examples that involve our half-angle identities. The first example is just going to be a pretty basic, straightforward one, using the half-angle identity to help us figure out the value of a trig function. And then the second example, we're going to be using a half-angle identity to help us solve a trig equation. So the first example says find the exact value of the sine of 75. So the sine of 75, this is not a common angle. This is not one that is normally on our unit circle. So much like we were doing with the sum and difference identities, I want to be able to rewrite this angle in terms of an angle that we already know, something that is on the unit circle, and then I can use the identity to help me find this value. So if I think about the sine of 75, and since I want to use a half angle, this is the same as the sine of 150 divided by 2. And 150, that is an angle that is normally on our unit circle. So then we can use our identity to help us figure out this exact value. So the identity for half angle for sine, I'll just jot that down here so we can reference it. So the sine of x over 2, this is equal to plus or minus, and then it's the square root of 1 minus the cosine over 2. So we do have that plus or minus here. However, the way we decide on which sign we're going to use, that's going to be based on where the terminal side of our angle is. And we want to figure out for 75. We don't want to use 150. So 75 degrees, that's in the first quadrant. So in the first quadrant, the sine has a positive value, so we're just going to do the positive. So the sine of 150 over 2, this is the same as positive, and that's going to be 1 minus the cosine of 150 over 2, and then the square root of that. So now the cosine of 150, that is something that is on the unit circle. That's going to be negative square root of 3 over 2. That's over 2. Still the square root of all that. And then, let's see, so we'll just kind of try and clean this up a little bit. So minus a negative, that's going to turn to plus. 1 plus the square root of 3 over 2. And then I'm going to get a common denominator here to combine these fractions together, and then I want to write this as just one single fraction underneath my radical. So this is 2 over 2. So it's going to be 2 plus the square root of 3 over 2, and then we're dividing that by 2. And then finally, so dividing by 2 like this, that's going to turn into dividing by 4. So nice and simplified. So 2 plus the square root of 3 over 4, and the square root of that whole thing. So there's our exact value. Again, I could take the sine of 75, I could type that in my calculator, but it's going to be some irrational number, some non-repeating, non-terminating decimal, which is not exact because we would have to round it. However, this answer with the radicals in there, that is exact. All right, now let's take a look at the second example. So solving the equation, sine squared, 2 times sine squared of x over 2, so there's a half angle, plus the cosine of x is equal to 1 plus the sine of x. So we are given a half angle to start with. So I would say whenever that happens, it's a good idea to use our identity and substitute that out. So this is a half angle and then it's squared. So I'm going to do sine and then our identity, which we have up here. So the identity for the half angle of sine, square root 1 minus cosine of x over 2. And then this whole piece is going to be squared. And then hopefully you can see that a lot of this is going to simplify very nice for us. The plus or minus doesn't matter. If it's positive and we square it, we end up with a positive. If we have the negative sign and we square this, it's still going to be positive. So we end up with 2 times, and then this fraction. And then take a look at the fraction. We're multiplying by 2. Have a 2 in the denominator, so that will simplify to 1. So 1 minus the cosine of x plus the cosine of x is equal to 1 plus the sine of x. So we have a positive cosine and negative cosine, so that will end up being 0. So we get 1 is equal to 1 plus the sine of x. So a lot of simplifying, a lot of canceling out. We have a 1 on either side, so we end up with the sine of x is equal to 0. And now that we have just a single trig ratio equal to a value, this is where we can use our inverse idea. We can take a look at the unit circle. So when is sine equal to 0? In other words, when is that y value equal to 0? And we just want this on the interval from 0 to 2 pi. So x is equal to, so sine is 0 at 0 degrees, at pi degrees, and let's see, so I did put a bracket here on 2 pi, so that one I'll also include. There we go. So 2 examples using the half angle identity help us find a value and to help us solve an equation.